So this is a video to go over the problem that I assigned, where you have an object that's shot at a disk and we're looking overhead. It's kind of like this thing, okay? It's got like a little Jenga block. And in the first scenario, it sticks to it. So we're saying it's made of putty. So it sticks to it and causes it to spin. And then in the second scenario over here, it bounces right back off of it. We're saying that it's shot at the same speed and it's the same mass in both scenarios. And the question is, which wumbo is going to be greater after this collision? So let's take a look. Initially, they have the same angular momentum. So L initial is just going to be mv r perpendicular. So r perpendicular is just going to be the radius of that. Again, r perpendicular is the shortest distance between the path of the object and your reference point, which in this case would just be the center of the wheel. So that'd be like here, and there, and there. So if we look at the scenario 2, or scenario 1 after the collision, the L final is going to be equal to just I wumbo, okay? And I is going to be I of the disk plus the I of the, the putty times wumbo. We'll call this wumbo 1 because we're going to solve for that. So if we set this equal to the initial, which is mvr perpendicular, then we get that wumbo 1 is equal to mvr perpendicular divided by I of the disk plus I of the putty. Now, do you have to do this? No, but it helps to do it in order to find your comparison. For scenario 2, okay, it bounces off. So L final is going to be the I wumbo of the disk. So it's going to be I disk times wumbo 2 minus this MVR. Okay, it's really plus MVR, but the V is going to be negative because it's flipped around. Okay, so I'm going to just move this over a little bit. All right, so if we plug in our initial condition, then we had MVR perpendicular equals I disk wumbo 2 minus MV, I'm going to call this like MV final times R perpendicular. So if we go and solve for wumbo 2, we get that wumbo 2 is equal to mv initial times r perpendicular plus mv final times r perpendicular divided by I of the disk. So if you compare this expression here and this expression here, then clearly this expression here is going to be a larger wumbo than this one here. Okay, why? Because notice we have mv r perpendicular in the numerator here, and on the right, we have MVR perpendicular plus other things. It doesn't even really matter how big those other things are. We have a larger numerator, okay? And in the denominator over here, on the left side, we have a larger denominator. We have I of the disk plus the I of the putty. Whereas over here, it's just the I of the disk, okay? So you could use this to describe it, but another way I like to describe it, okay? I'm going to erase this stuff because another good way to describe it is this. And that is to talk about the change in angular momentum, the delta L. So delta L in scenario 1 is going to be smaller, okay? And delta L in scenario 2 is going to be larger. Okay, the reason for this is because in scenario 1, it sticks. So the angular momentum of the putty before the collision, so it's moving to the right, okay? And obviously it's going to be going slower, so it's going to lose a little bit of its velocity, okay, and therefore it's going to lose a little bit of its angular momentum. However, in scenario 2, it goes all the way to 0 and then turns around and becomes negative. Okay, so if you have an object that changes direction, that is a comparatively large change in angular momentum compared to if it sticks to it. Okay, sticky is always like it loses a little angular momentum. That means that the disk will gain a little angular momentum. But in the other scenario, it turns all the way around. So again, the change in angular momentum of the ball or the putty is going to be equal to the change in angular momentum of the disk. So scenario 2 had a much larger. Whenever you have a bouncy collision and you're comparing it to a sticky collision, the bouncy collision is always going to be a larger change in linear or angular momentum. And a sticky collision is going to be smaller comparatively. All right, so that's what you'd want to do for this question and how you'd want to answer this.